Welcome to Unit 1, Lesson 9, Review. We are working on adding and subtracting unlike mixed numbers. Our target goal is I can use equivalent fractions to add and subtract fractions by adding and subtracting mixed numbers with different denominators. All the skills in this lesson actually have been gone over in all the other lessons. It's just putting them together with mixed numbers. All right. First of all, I want to review probably one of the toughest skills for people is getting a common denominator. Let me do this in an efficient way. If I have to subtract these fractions, 2/3 from 9/10, I need a common denominator. So how do I decide what I should use? The first thing I say is one factor or one denominator a factor of the other? Is 3 a factor of 10? No, nothing multiplied by 3 is 10. So I'm got to move on to my next question. Is 1 the only common factor of the denominators? Is 1 the only factor that these two have in common? Well, the only factors 3 has is 1 and 3. We already determined 3 is not a factor of 10. So yes, 1 is the only common factor of the denominators. So we're going to use the product of the two denominators as a common factor. So we are going to use 3 multiplied by 10, 30 as the common denominator. Let's look at the next one. 14 and 7. Is one denominator a factor of the other? Yeah, 7 is a factor of 14. 7 multiplied by 2 is 14. So we can use 14 as a common denominator. In fact, let's show what I would do. I would pull 2 7s off somewhere, and I would take and say what times 7 is 14 is 2. So I'm going to be making my pieces 2 times smaller. So I need 2 times as many to be multiplying by 1. And that gives me 4 14ths. And then I would rewrite my expression. 9 14ths does not need to be changed. That's why this is my first question I ask. Subtract 4 14ths. Why don't I take a look at this one now too? Remember we decided that we had to use 3 multiplied by 10, 30 as our common denominator. So what I would do is somewhere else, I would pull 9/10 and I would use my other denominator 3 as my multiplier. So 3 as my numerator and 3 as my denominator. 9/10 equals 27/30. And I would pull 2/3 off somewhere. And actually, I don't even need to pull it off somewhere because I'm multiplying them both by 10. And that's pretty easy mental math. I'm using this denominator as my multiplier, so 3 multiplied by 10 would give me my 30, so I have a common denominator. And 2 multiplied by 10 is 20. And now it's just subtracting my numerators. All right, looking at the last one. So this one, we had to multiply our two denominators and use that product as our denominator, or as our common denominator. And this one, all we had to do is change one of them because it was a factor of the other one. Now take a look at here. We have 8 and 12. Is one denominator a factor of the other? Is 8 a factor of 12? No, nothing multiplied by 8 is 12. Is 1 the only common factor of the denominators? I know 1's not the only one because they're both even, so they both have 2 as a factor. In fact, 8 and 12 also have 4 as a factor. So what am I going to do? I am going to find the least common multiple of the denominators and use it as a common denominator. So I'm going to think of my multiples of 8 and 12. If I need to, I'll list them. I know my 8s and 12s pretty well, so I wouldn't need to, but if you don't know them super well, you might just want to list your multiples. My multiples of 8. 8, 16, 24, 32, 40. So we're just going to list our first 5 multiples of 8. And now my multiples of 12. 12, 24. Hey, I recognize that one as a multiple of 8. I also just knew it because I like to play Math 24 a lot. 36 is the next one. Multiplied by 4 is 48. That would be our next common multiple. 6 multiplied by 8 is 48. So I'll write that one for us. What do we have in common here? We have 48. But we also have 24. And I want to use my least common multiple. Least, meaning the common multiple with the least value. So I'm going to use 24. All right. I'm going to make myself a little bit of space here by getting rid of that. So then I need to pull my fractions and figure out what would I have to make them into to have that common denominator. So 8 multiplied by 1, 2, 3 makes 24. So I have to multiply 5 by 3 also. Gives me 15 24ths as an equivalent fraction. Remember, our target is to be able to add and subtract fractions using equivalent fractions. 1/12. What times 12 was 24? 1, 2. So my multiplier is 2 here. 2 times 12 is 24. It takes 2 halves to make a whole, and I want to multiply by 1, so I'm not changing the value. 1 multiplied by 2 is 2. 12 multiplied by 2 is 24. So 1/12 is equal to 2 24ths. That is a key skill. We have to be able to figure out what to make them. I will tell you that you can always just multiply your two products together, or use the product of multiplying the two denominators together. But think about that. 8 multiplied by 12 is 96. I'm starting to get into some big numbers there. Bigger chance of a mistake. So let's take a look at adding and subtracting mixed numbers with different denominators. All right, guess what? Right away, look what I have to do right from the gun, is I have to figure out common denominator, don't I? So 6 and 9. First thing, is 6 a factor of 9? No. 6 multiplied by nothing gives me 9. Is 1 their only common factor? No. I know that the factors of 6 are 1 and 6, but 6 is not a factor of 9, and 2 and 3. And 3 is a factor of 9 because 3 multiplied by 3 is 9. So they have a common factor less other than 1. So then I think of my multiples of 6 and 9. If I need to, I would even look at a multiplication chart. Look across the 6s and the 9s. What's the least common multiple they have? Well, when I look down my 6s, I see 6, 12, 18. Oh, I know that 9 times 2 is 18. So my multiplier for this one was 3. And my multiplier, so I multiply that. Don't forget to keep your whole number. And that's 15/18. Common mistake that we make is we don't keep our whole number. And I know that 2 multiplied by 9 is 18, and 2 halves make a whole. Again, I'm adding. It's still 2, but it's now 5 times 2, 10/18. Now, 15 plus 10 is 28, and they're still 18ths. Just like if it was 15 apples plus 10 apples, I would have 28 apples. 15/18 plus 10/18 are 28/18. 5 plus 2 is 7. Now, I notice I can take a whole out of 28/18, which makes sense. Both of these are greater than a half. So how many 18ths make a whole? 18 of them. So I'm going to group 18 of these 18ths. That'll leave me with 10/18 left. Those 18/18 are going to give me one more whole. 7 plus 1 is 8. I end up with 8 and 10/18. Some of you might notice, hey, 10/18 can be simplified. I'm going to pop it down here. All right. So 10/18 could be simplified. I can take and divide the 10 and the 18 by 2. Now in 5th grade, we don't require you to simplify your fractions, but in 6th grade, they will start to. 10 divided by 5, or 2 is 5. 18 divided by 2 is 9. So we ended up changing them back into ninths. 8 and 5/9. Now, subtracting its numbers. Again, just like before, we need a common denominator. Funny thing is, just like this one, or no, that one wasn't. First question, is 3 a factor of 15? And it is. So all we have to do is change our thirds. What multiplied by 3 is 15? 5. So to make my fraction I'm multiplying 1, I need to multiply the numerator by 5 also. That leaves me with 4 and 5/15. Now, that's the most efficient way because I don't have to change this at all, and it's using the smallest numbers possible. Now, I chose this one on purpose. I start with my fractions. I'm not going to want to go in the negatives. So, I'm going to ungroup one of my wholes. I don't have enough. 5/15 subtract 7/15. I don't have enough to subtract them. So I need to get them from the whole number. Let's take a look at that. So we're ungrouping one of our wholes. Since one whole equals 15/15, 4 and 5/15 equals 3 and how many 15ths? So I'm going to replace one of my wholes. I'm going to replace one of these. So that's how come I only have 3 of them left, with 15 15ths. So I'm replacing one of those with 15 more. That's going to give me, let me just see something else. That's going to give me, no, doesn't say. That's going to give me 5 plus 15 is 20 15ths. Now, before I show you another way to do that subtraction, right here is taking 4 and 5/15. Here's 1 whole, 2 wholes, 3 wholes, 4 wholes, and 5/15. Look what how I can show you. Here is 3 wholes, and there's my leftover 15ths. My 15 15ths plus my 5 others, which is what gave me, here were my 3, and here are my 20 15ths. So, showing you that again, I ungroup one of these. So 1 less than 4 were 3 of them. That 1 whole gave me 15 more. 15 more than 5 are 20 15ths. Now, 20 15ths is easy. I can subtract 7 15ths from 20 15ths is subtracting 20, subtract 7 is 13, and their size stays 15ths. And then my whole number, 3 subtract 2 is 1. Now, the other method that they were showing back there was I can change both of my mixed numbers into fractions greater than 1. 4 wholes is how many thirds? Well, we know we have to go 15ths, so they just went 15ths right away. So they went with right here. When they got here, they changed them. So 4 wholes is how many 15ths? 4 wholes ends up being 15, 15, 15, and 15, or 60, plus 5 more makes 65. Earlier in a lesson, I talked about a quicker way to do that. 4 multiplied by 15 is 60, plus 5 makes 65 15ths. Why that works is because 4 wholes, every 15 15ths makes 1 whole, so I have 4 groups of 15 15ths. 4 times 15, which is 60, plus the 5 more I had, 65. To change 2 and 7 15ths to 15ths, 2 multiplied by 15 would be 30 15ths, plus 7 are 37 15ths. The reason some people like to do this way is they do not have to do any ungrouping. But the problem is this. Now, after I subtract, I have bigger numbers to subtract. 65 subtract 37. Well, 65 subtract 30 is 35. Subtract 5 of the 7 would be 30. Subtract 2 more would be 28 15ths. But now I need to turn it back into a mixed number. How do I change a fraction greater than 1 into a mixed number? I divide. Take the numerator, 28, divided by the denominator, 15. Well, 2 15ths is 30, so I only have one whole 15. One group of 15 is 15. And when I subtract, I have 13 remaining. 13 is what was left of my numerator 28. So it goes up as my numerator. And the size of those pieces were 15ths. So they are still 15ths. So it ends up equaling 1 and 13 15ths. So those are all the things that should come up when you're adding and subtracting mixed numbers. Feel free to look through this video. If you go back, like I said, you have learned all these skills before. Good luck.